Hey Spring fans! Today we're going to go ahead and take a look at some of the low-level interfaces in the Spring framework itself that allow you to write code that is more aware of the application context and container. Why you would want to do this is sort of it varies by case, of course, but suffice it to say you shouldn't have to do this very often. So I just want to explain some of what these things are, what some of these opportunities are, and I want to show you things you may have seen but didn't quite understand because it's not very common to use some of these things in the Java configuration-esque sort of world of Spring Boot and Spring 3.0 or later. But if you've got old code, you may have seen these things around. So this might be a useful primer on some of those things, and maybe you'll even learn something new as well. So we're going to go ahead and create a new project here called Spring Aware. I'm not going to bring in anything specific. I don't need anything specific. I'm just going to use Spring Framework itself, the application context, and all of that gets set up for me by the Spring Boot starter default dependency that gets added by choosing nothing on the Spring Initializer. So I'll start this up, and what we're going to talk about today we're going to talk about several different things. The first thing we're going to look at is how to manage the life cycle of an object, right? So again, let's go ahead and create a couple of classes here, right? Two objects that work with each other, one with the other. Say class foo, class bar, and they're related to each other, right? And so in theory, one could have a dependency on the other. Create a constructor. Now, I have an object here, and I can do the initialization of the foo entirely in the constructor, right? This is a good place to put that logic because insofar I've got all in that I've got all of my collaborating objects required to set up this object in a valid state provided in the constructor. I'm good to go. But sometimes I may have setters. I may have other things that are provided later on. So maybe I don't get them all in the constructor. Maybe I have a initialization that happens via a setter here, right? So we'll say setter, voila. Now I need some callback, some hook after both the constructor and the setters have run. And for this, we're going to look at we're going to look at the Spring Initializing Beam interface, right? So Initializing Beam is an interface that's been in Spring since day one, since 1.0 at least, and sometime before that as well. And here we have an ideal opportunity to do kind of validation, right? I'm going to validate that the bar can't be null, right? If it is null, then we'll have trouble. So let's go ahead and now define a bean of this type foo. We'll create a bean provider method here. We'll say bean foo, return a new foo. And obviously this is going to throw an exception because it doesn't have a bar yet, right? So we have to instantiate the foo with a bar in order for this to work. But let's prove that our after properties method is being called. This after properties method is also a great place to do any kind of complex state setup and so on, right? So it's a natural place to do that. So there we go, bar can't be null, which is what we expected, right? We can also imagine wanting to do this. We can also imagine wanting to handle destruction logic, right? Here we have a nice secondary constructor, if you will, to do this kind of stuff in the after properties method. Perhaps we want to do construction. Maybe we want to explicitly null out this field to trigger to the garbage collector that it can be garbage collected, right? Maybe this is a dependent or scoped bean, for example. So in this case, we can also implement disposable bean, right? So disposable bean is a callback that's also, it's the mirror image, if you will, of initializing bean. And so here we're going to say this dot bar equals null, right? Remember, Java, unlike C++, doesn't have an explicit notion of finalizers, but dereferencing a variable can help give the garbage collector an idea of the freedom or the latitude it has to garbage collect objects. So this is very, very convenient. Now, this is very invasive, right? In this instance, my plain old object, my service perhaps or whatever, is aware of Spring. And that's not such a big deal. I mean, you're going to be aware of Spring anyway, but one could argue that lifecycle callback methods in particular should live or work regardless of the container. So, and that's true, of course, right? There's no reason you couldn't, for example, remove those interfaces, especially using Java config, right? If you have XML, there's no reason you couldn't just say, like this. You couldn't just call the after property set method foo dot after property set and so on, and everything will be okay there as well. But that requires the consumer of the code to call that method. So I suppose the real argument here, the best way to do it is just use object-oriented best practices and pass them in as constructor arguments. However, you may want to have secondary construction logic like this, and you want to have it automatically invoked when using a container that understands them. So for this, we can use JSR 250. JSR 250 is a very old standard. It came out in Java EE5, and it describes basic lifecycle hooks. So here, I can use at pre-destroy, and here I can use at post construct and at pre-destroy, right? So here, pre-destroy. Now, if everything goes to plan, we should see the same initialization error, right? The validation logic should be in place. So there we go. We can see that the same effect is in place, right? And this, by the way, the name is completely arbitrary after, right? Or setup, whatever you want to call it, right? It doesn't matter, right? The name of the method is completely arbitrary. Now, this gives us some control over the life cycle of the object. Naturally, we may have a more complex object than just a single field that may or may not be null. Maybe we have maybe we're trying to create an object that is long running. Maybe you're managing something very, very stateful and heavy, and you want to be able to start and stop and destroy and garbage collect and manage these heavy resources based on the lifecycle of the application container. This is very common, for example, in Spring integration, where we have a lot of different adapters that can be used to work with the outside world. These adapters spin up, they start monitoring an external event source for some sort of change, and then based on the event source, they publish information into the application context for downstream components to use. Spring integration is very stateful, right? These adapters are stateful. When I'm receiving messages from a message queue, I take the messages off the queue, I process them, I send them downstream, etc., etc., etc. So in this case, we need a little bit more than just object initialization and destruction. We need to think about how to manage a service. And so the first, the class in this case is the hoist or the hook that creates that service. So we're going to create an object that implements the smart lifecycle callback methods. Now, smart lifecycle in this case is actually fairly simple, right? So a smart lifecycle object is just an object that actually implements lifecycle. And I suppose we should start with that one first. So let's go ahead and reduce it down to just the contract of lifecycle. Here we are. So you've got a start, a stop, and a running method. And in these methods, you can see whether the application, we can see whether the component is running, whether the component whether the infrastructure that with which the component is working is running. And you have methods here to explicitly start and stop the service, the thing. The enhanced version of this is called Smart Lifecycle. And Smart Lifecycle gives you extra methods here. You can tell Spring to automatically start this component up or to not. You can provide a destruction callback that happens when the JVM gets shut down, when the application gets shut down, or whatever comes first. You get a callback here for starting and stopping, but of course stopping may not happen quick enough, right? So it's very useful to provide a custom runnable that can be run on the JVM's shutdown hook. And we have here a status object that we can use to determine whether the object is running. And we also have this idea of a phase, the order in which this application should be executed, right? So that is very, very useful in particular. So phased objects are useful if you have something very stateful. Perhaps one is dependent upon something else, right? So we have here the interface, and we can see there are different well-known phases. Sorry, you can see that the phase is just a number, right? The number by default is 0, and that just means it has no particular import, right? No particular importance. But it's up to you to provide that phase if you want for ordering purposes, right? So it gets used here in the lifecycle processor, the default lifecycle processor that Spring uses to honor the presence of the lifecycle interface in code. It ends up creating objects. It ends up putting objects that have the same phase in the same lifecycle group. So in this way, you have a sort of a way of saying this is going to happen before that, etc. Okay. this is for long-lived components. This is, again, I think by the time you need this, you're very much in the realm of writing a component that is explicitly leaning on the lifecycle capabilities of the Spring Framework container, not just instantiating plain objects. Sometimes you have complex objects that are more, or maybe you have objects that you don't instantiate directly. Maybe you have objects that live somewhere else, or they are external to the application context, and so you want to provide a definition for that object. A case in point, of course, is anything you look up from JNDI. Now, JNDI is a directory. It's a Java name. It stands for Java Naming and Directory Interface. It's a way of looking up keys and values in a context, which is common in a lot of application servers. So this is a very kind of old idea, but it's still very germane to what we're trying to do here. In the case of JNDI, Spring doesn't instantiate the objects. Instead, it manages an object in the context by looking up the object in some other thing, in some other memory in the JVM somewhere, right? So in the case of the application server, it's memory being managed by the application server, co-located with your application. So we want to be able to dereference that object to look it up and to make it available to our code. So maybe we want to look up a data source. The application server will manage the data source, it'll manage the connection pool, it'll provide all that for us, and we want to use that in our Spring managed code, so we want to inject the data source. Here we could use a factory bean, right? So we could actually create a JNDI factory bean, right? JNDI object factory bean. JNDI object factory bean like this, and the JNDI factory bean has a lot of parameters that we could provide, right? So set the JNDI name, the JNDI template if we want, the resource ref, the expected type if we want, a lot of different things that we could provide here, including property values that we can use to dereference the JNDI environment, to resolve the actual environment in the first place. All of this stuff is expected to be provided, but then finally, once all that's done, Spring, once we return that, we return FB, right? Spring will take all of those variables into account, the factory bean will take all those variables into account, and then use them in the getObject method here. So getObject, which returns this JNDI object, which of course is the object that was looked up for you after properties method was set. So here we're saying JNDI object equals JNDI object project factory dot create JNDI object proxy, etc., etc., etc. Right? And so otherwise we're looking it up. So the construction of the object is very complex, but we don't care because all we need to know is that we're going to have a data source of the right type that'll be managed for us, right? So we can, when Spring runs this, it's not going to actually manage this factory bean. In fact, instead, it's going to manage the product of the factory bean. In this case, the product of the factory bean will be the object that gets returned by calling into the JNDI context like this. Look up with the JNDI fallback. We got an object that gets returned, and the type of the object in this case is just Java-lang object. But Spring likes to know, it likes to know what the type can be cast to if necessary. So, for example, it provides a callback interface here, a contract in the factory bean method, or rather interface called getObjectType. And here, you're supposed to return the type of the object that's being returned so that Spring can do validation. Before the application starts up, it wants to validate that there are objects of a certain type in the context. Maybe it sees a reference for a data source in some component code that needs to be injected. It doesn't know where to get it yet. It just wants to prove, or just wants to know if there's anything in the context that will eventually result in a bean of that type. And the factory bean will result in the bean of that type. So by having that callback method, we can avoid forcing Spring to instantiate aggressively and early the data source before it's needed. So let's take a very simple example. Let's say that we want to create a public static class foo, and we'll take we'll create a public static class foo factory bean, implementing factory bean of type foo, and we'll create our own very, very simple foo. Okay, so again, the idea here is to have complex initialization to hide that logic. Maybe foo is actually an interface, right? In this case, we have public static class foo1, public static class foo2, and of course this doesn't need to be static. And maybe in the case of my factory bean, I want to have a boolean that says prefer 1, right? So I'll say that that's going to be true by default, and but it could be something else. So we'll create a setter. There we are. And we know that the object, no matter what the type, is going to be of type foo, so we can tell Spring about that. We can tell Spring about that here in the object type method. We know it's going to be. We know that it could be a dependently scoped thing. We could have more than one in the application context. So I just like to leave this false by default, but I suppose there's no reason, if you're absolutely sure that there's never going to be more than one, that couldn't be true. That said, that is merely a suggestion. There are some use cases where Spring will override that behavior, that value. So keep that in mind. Now, let's create the foo. Here we're going to say return this dot prefer foo 1 or prefer 1. If that's true, new foo 1. Otherwise, new foo 2. Okay, so we're creating a different object based on configuration. So this is not the same as varying the construction of the object in the construction itself. Now, you could actually just stick an at component on this, but remember, you're going to use these factory beans more than once, right? So I would say at bean foo factory bean foo return new foo factory bean. There we are, and the foo that I'll get by default in this case is the first one, right? The foo 1. I could change that, right? So again, what I'm doing is I'm creating a factory bean. Spring doesn't care about this object here. It doesn't know about the factory bean. It sees the product of the factory bean, this one here. This is very common, especially before, where he had complex initialization, and the only way to create these objects in Spring was to use XML. Now, of course, we have Java configuration. So these Java configuration methods are very, very versatile. You can do anything in Java that you want here to arrive at the objects. So there's no real reason to have this extra adapter. I mean, it's a nice place. It's a nice idea. It's a nice place to sort of codify construction, right? Construction is a very interesting thing to do. So this is an implementation of the factory pattern. But it is very much a thing that I wouldn't recommend, particularly for new code. If you're using Java configuration, you can get away with creating the objects in the Java config method itself, or use a builder or a custom object, right? We have custom objects that do a lot of the hard work for you. So you can say return new JNDI data source lookup, JNDI data source, no, locator, delegate, lookup, and then pass in the JNDI string, right? So you get a lot of functionality out of the box. You don't really need the factory bean anymore. But if you see it, it's very useful to understand what it's doing, right, and to understand how to work with it. There are a lot of factory beans in Spring, as you can imagine. In my mere class path with just a few Spring jars on the class path, I've got all these different factory beans that allow me to create caches and date time formatters and JMX infrastructure and services and thread pools and task executors and YAML factories and all these different things, right? These are all just what I've got in the class path, and they've been around forever. In this last section, let's take a look at the new nicety, a nice tool inside of Spring Framework 4.3, which if you're using Spring Boot 1.4 is already included. Spring Framework 4.3 is fairly new, having just come out earlier this year, and it includes a nice feature called Injection Point, which is very much inspired by a class of the same name in CDI. Okay, so Injection Point is very, very useful if you want to make your code aware of the object into which it's being injected. And it's pretty hard for me to think of any other example besides the one that's kind of bandied around pretty commonly, which is that of a logger. So we're going to go ahead and create a logger. We're going to say, I want to create a logger, and I'm going to use the injection point type here to create a logger that is aware of the class into which it's being injected. So I'll say injection point dot get declaring element or get declaring type, get name, or rather get member. Get declaring class, get name. Okay, so I've got a logger that I'm providing, and now I can create a component that needs it. But of course, I'm going to have multiple components, right? I'll have multiple components that each have their own logger, right? That's the whole point. I want to have a logger that has for its value here the class in which it exists. Otherwise, I would have otherwise I could just do it the old way. So logging component. If I did it the old way, I'd have something like logger dot get logger, right? And I just say get class, and that would work certainly, but it ends up getting tedious, right? So in this case, I'm going to just inject the logger, and now I've got it centrally managed. I can actually change the configuration once, and it affects all so configured loggers. But because I may have multiple components, each with their own class, I don't want a singleton, right? This won't work. I want to make this scoped to a prototype. So I'll do that. I'll turn this into a prototype. You may use it for other scopes as well. You may say, oh, I want to have a session scoped or whatever. But the point is, prototype is fine. It's a cheap enough object. It doesn't really matter. So I've got now an object that's going to be injected. And again, I could make this add auto-wire. But remember, another nicety in 4.3 is that I don't need to. Okay, so let's just use the logger. Hello, world. And now we can start that up, and we should see the logger logging as though it had been defined inside of the logging component, which of course is in turn defined inside of the Spring Aware application. And there we are. There's our hello world. Okay, so that's a very cool feature, I think. I think it's very useful. You'll find a lot of use for that, hopefully, in your code. Certainly, it's not the only way to get a logger. When I talked about this on Twitter at Starbucks Man, a few people responded with mentions of the Groovy @log annotation, which the Groovy language itself has a lang annotation to do that, and Lombok, presumably borrowing or at least being inspired by what you can do in Groovy, also has an SLF4J annotation, both of which use a code sort of compile time or run or basic initialization time magic to insert or inject a logger that you can use with a well-known variable type. And that's all well and good. I just think this is a little bit, this is nice if you're using Spring and you want to remove those public static final loggers from all of your code. All right, well, with that, thank you very much. I hope you enjoyed. I'll see you around in the next